Hey everyone, can you hear me well? Yeah? Okay, so today we're going to be talking about DPCB, which is an InstaDeep product. So we're doing place and route with reinforcement learning for PCB design. So we're at DAC, DAC number 62, it's 11:15 a.m., session 15 in San Francisco, and let's get started. If you look at real-life PCB design, it's going to be taking some time, it's going to be manual, you're going to have to work with tools that are not the best, there's always something you have to change, it's a bit slow, it's not automated. Plus now you have a shortage of components with everything that's happening in the world, and a shortage of talent. Because now when they're out of university, like a student in electronics, they might not want to spend their days doing place and route of PCBs, they might want to do artificial intelligence, consulting, or even something else. This, plus the pressure of always releasing products with everything you have in new technology, kind of like makes the problem of PCB place and route quite important, and this is something that has to be addressed. If you look at the problem a bit more like from a straight point of view, you have combinatorial search, so you're trying to place hundreds and thousands of components on PCBs that can be like this, like that, but ultimately it's placing lots of things and you have so many permutations that it's very hard to even try 10% of everything that can be done. The cycles that you see in manual design are just too long. Each time you change something, you remove a constraint, remove a wire, replace a component, you might have to redo the entire process, and in that case it's just impossible to get something efficient. And if you want to rely on heuristics, so everything that is rule-based or simple model-based, you're going to have very fast tools that are going to take lots of shortcuts and not respecting constraints. So one example is like, if I take an open source auto-routing software, they might give me a solution that connects my entire board in like a few minutes, but when I look at it, the plane is going to be cut, the diff pairs are going to go like that, and this is just not acceptable, it's not going to work in real life, right? So we're trying to address this problem with, of course, humility, but we can already do something that is useful, of course. So DPCB is very fast. In a few minutes, you can already start getting results, and the longer you give it to actually work to place and route your design, you're going to have something that is actually pretty good. All our designs are DRC clean at each iteration, so each time we give you a new solution of like placement or routing, everything is going to be DRC clean, so you don't need to worry about this part of verification. There might be other verifications that you want to do, but not this one. And with time, of course, we're making our product even more interactive with more control for the designer. So at the beginning, it was just about clicking and getting your solution. Now you can pause, you can see what's going on, you can make a few changes, and you can restart to make sure that you keep the maximum control. And the way we do the optimization is letting the user choose the metrics that they care for. So by default, we say, okay, we're going to fully connect the board, we're going to minimize the total wire length, and we're going to make sure we don't have too many VIAs, right? But if you care about something else, it's something that is easily injectable into DPCB to make it work. And how do we do this, right? So we've been saying AI, we've been saying PCB design. You know, LLMs are kind of like everywhere here today. We might be the only company doing AI at DAC who is not doing LLMs because we're doing reinforcement learning. So reinforcement learning is very simple. It's the kind of agent you would train for such a game here. So agent in a simulation environment, taking action, getting a reward, and iterating. It's trial and error, right? And the good thing is that number one, reinforcement learning has learning in there, so it's learning from something, and what it's learning from is past experience. So the more data you see and the more problems you try to solve, the better you get because you're ingesting everything especially with the AI models you see right now in the compute, etc. And then when you have a system that has learned or partially learned to place or route PCBs, then you have very fast inference because we're using neural networks, so you just need to deploy them on like CPU, GPU, etc., and you're going to be able to find a solution. So now if you get more in the utility/technical part of the presentation, we support all of these tools pretty natively. So if you work with, let's say, KiCad, you can take your project, export it, get the KiCad PCB, the KiCad Pro, give it to DPCB for placement or routing, and it's just going to work. We're going to load the constraints in the right way. We're going to get the clearances. We're going to get everything you need, maybe including the differential pairs. And then when you're done, you can just re-export the project into the original file format, load it back in your interface, and it's going to work. Now, kind of like makes sense to talk about the features of support, because we're saying we can place and route. We said that the designs are DRC clean, but there are other things, of course. It's not just about having a DRC clean design that makes sure that the differential pairs are going in the right direction, right? There's so much more. So what we do right now is support all sorts of constraints that you have in standard, let's say, as we say, medium-sized commercial/enterprise boards. So we do multi-net routing, multi-plane support. We route the differential pairs, and you can even, if you have a pin exit that is complicated, continue from the manual fan out. So we can support partially routed board, which means that as a user, if you're working on a design and you've done 10-20% of the design and you're happy with what you've done, and you just don't want the AI to kind of like finish it because it's not that interesting and you want to move on to something else, this is something we can do. So today we have 15,000 designs and going in DPCB that have been submitted since the launch of the Pro version in September 2024. So that's already pretty encouraging. And this is growing. Of course, we have lots of partners. And I wish I had information on the actual boards that were manufactured, but we don't have this information. Maybe we'll try to get this for another time. In the future, there's the near future and there's the kind of like long-term future. We're going to try to add a few more things to DPCB. So one of them is supporting Allegro rule files. Right now, of course, we get the Allegro export as a DSN Spectra-like, but you can also have some additional rules that are usually on clearances and things like that that we are almost supporting. It's going to take a bit of time. And at the VIA level, there are types of VIAs that we're also in process of supporting. It's going to be implemented probably in a month or two. And then later this year and even next year, we have a whole lot of new features that are mostly driven by our users and customers. So this is pretty exciting, of course. If you're trying to use DPCB now, you mainly have two options. Either you want to go to a website, have a web app, and then click on place and route and see what's happening. Or if you're more tech savvy and you want to stay inside your tool, you can use our API. So it's very simple. You have an API key that you get from DPCB. You can have the scripts, you can have the swaggers pretty much easily. We can provide you with everything. And then you stay inside your tool, call DPCB, and see it place and route your board without you having to go to another website, come back, etc. So it's minimal intervention. On the other hand, if you use the web app, you still have the layouts that are exportable and ready to use, and you don't need to set up anything. So maybe if you're less technical, it's a good option. And then for enterprise, we're very wary of cybersecurity, confidentiality, privacy. So we do on-prem deployment, and our cloud is kind of like secure as well. So that's pretty good. To give you a few examples of what DPCB can do, of course we have a demo later, but this is already kind of like a good idea. We took 3 open source Arduino boards, 2 to 4 layers. I think they're not too complicated. They have planes here and there. And you can already see that you get results in a few minutes with interesting routing patterns, right? So if you take for instance, the micro top right, you see how the exit of the central unit is kind of like pretty parallel, and then we have some horizontal and vertical routing on different layers because it's something that can be quite desirable as a feature for an auto router. We're also doing placement, as we said before. So, of course, some of the constraints we're trying are to minimize the wear length to decoupling capacitors. We can protect components. We take into consideration the fact that we have oscillators, etc. And of course, since a good placement leads to a good routing, if you improve one of them, it's kind of like reinforcing the loop and making you have a design that is usually more efficient. So to give you a quick super quick example of place and route before we go into more detail. We manually created this super small chip. We just took 48 capacitors and we started our placement tool and just went to the first solution, like 2 minutes. And then we tried routing it, and the placement was so bad that the routing looks like a mess. So 10 hours of routing, 2 hours of placement. But then, if you take a bit more time to let the placement actually do its job for like 30 minutes, then after an hour of routing, it's able to do a pretty nice routing that is going to make, of course, the overall board, well designed and probably more efficient. And we have a small animation here of, this is a public open source board that we found online a couple of days ago. Kind of like gives you an idea of what placement and routing look like inside the PCB. So this is kind of like real-time GIFs. You see the placement here, the components have started outside the boundary and now they're in there. And then obviously what we're trying to do is to have the colors close to each other in the placement, because this is how the constraints are made. And then on the other hand, you have the routing with kind of like RF protection to the right, differential pairs, the plane, etc. So this one is a 4-layer board that has differential pairs, planes, etc. So that's pretty much how it is. And now I think we're going to do a quick live demo to show you what DPCB can do in real life. It's going to be this board on the right. So we exported it from, exported the board from KiCad just as it is. We're just going to do routing. So I'm going to click routing here. I'm going to do KiCad. I'm going to import my KiCad PCB file and my KiCad Pro. So this is just purely taking the file from KiCad and putting it in there, nothing else. Submit. Then we're just waiting for the system to kind of like load the board, understand what it's doing, etc. So note that right now, no AI is happening. It's just reading the specs and telling you what it sees. So right now, okay, maybe I have these different net classes. If I need to change something, I can, but for the purpose of this demo, we're going to leave it as it is. Then it's going to tell me if it detects or not differential pairs. In that case, it did. Obviously, the gap is set to 50 here. We could change it if needed. We're going to leave it as is. Then there's another concept, which is net priority. In there is no net priority. So what the tool is doing here is just telling you that it's going to be the same for every of them. And if you want to change the way the priorities are designed, you can either change them here or use a simplified system that will also take care of it for you. Now we're moving to the layers here. And what I can see pretty simple is 2 signal, 2 power layers. For each layer, I can see the planes and the nets that are allowed to live on those layers. So if I want, as part of maybe signal integrity, like remove nets from certain layers, you can do that by just changing it and making sure that some nets don't live on certain layers. So that's also pretty useful, depending on what your project is. Then maybe a bunch of warnings, because I just exported the file without looking, but this is what the board looks like. It's just placed, and now we're going to route it. So you see the components are there. You can already have some kind of view of what your board is. You can see the rat's nest, etc. And then when you're ready to go, you can confirm. You can always go back if you need to change something. But now we're going to confirming. And it's going to generate a preview of the board. It's going to start doing the routing, and while it starts, you can start examining the different things. You can remove some planes if you want to see exactly what the board looks like, have a better view of the components, see the routing, and then you see that it's starting. So I already have a solution in 22 seconds that connects the board at 72 out of 98 connections. Okay, 76 now in less than a minute, and this is pretty much straightforward. Now you just wait and see, and you're going to see that in less than a minute, it's going to be fully connected. So this is a small 4-layer board. It has differential pairs, has a few planes, etc., and it's pretty seamless in DPCB. And what's pretty interesting is that, with all the agentic AI, etc., we're going towards more automation And for us, it's also important to have the user to be able to have control on what they're doing. So something we're just introducing right now is if you stop a run because you want to download or do something else with it, of course you can download the file in the way we want. But we have a new kind of like feature that is if you zoom on some parts and you decide with this small scissors thing, like right click, to rip up, you can get rid of some parts of the routing that maybe you don't like and you want to be redone. And then the entire wires from both sides of the kind of like segment that you removed are also going to be cleaned up. And the AI is going to give it another try. So I'm just going to remove a few of them. And then I'm going to say, resume the board. Okay. And here we are. So you see here it shows a small kind of like key saying that I decided to remove some stuff. It's going to clean it up. And then it's going to reroute it. So that's kind of like the first step towards making it interactive. Is going to be, of course, much more interactive in the future, but that's already pretty good. And as you can see, this has been running for like, let's say, a minute. A minute is 50 cents in US dollars, so that's very cheap. Even if you let it run for like 10 minutes, it's going to cost you $5, so that's pretty good. Yep. I guess we can let it run, but that's pretty much it. Happy to take any questions you may have. Hi.
Well, can you make different versions of routing instead of just one final results?
Of course.
If I want to have different versions, different variations.
Yeah, so the question is whether we're able to have different versions of the routing instead of just one final, of course. So as you can see here, all the solutions that have been selected by the agent to be seen by the user are pretty much here. And I can easily go back to one of them, right? So by just clicking here, I can select it, inspect it, and I can download specific solutions as well. Does that answer your question?
Yep. And I have one more question. Can you also change the, make it have a different VIA locations and different versions of routing with different locations of the VIAs? If it's multi-layers.
Yes.
Let's say 6 layers.
Yeah, we can go up to 8 layers. That's the official size we support. Maybe we can go a bit beyond that. And I think you were asking about changing the VIA locations. Yes, so this is something we can do, but is not yet available in the web app. It's going to come very soon, but this is something that can be done very easily, yes.
But I guess right now it's the same layer. You can change the different. You can have a different versions, and you can vary the routing, right?
Sorry.
You can change the routing in the same layer at least.
Yep.
If the VIA location is fixed, then you can change the routing.
Of course.
Okay.
Yeah.
Thank you.
You're welcome. Any other questions? Yeah, of course.
Yeah, one more question. Can you set the range of angles, the constraints for this routing, like the maximum angle you can take and the minimum length after it changes the direction, things like that?
Yeah, this is something we can do as well. Yes, you should get in touch, and maybe we can do a demo of what you're looking for.
All right, I think that concludes our session this morning. Thank you for joining us. Our next session starts at 12 noon with Siemens here at the Exhibitor Forum. If you have any more questions, I'm sure he would like to answer your questions on the side of the stage or at his booth.
Yeah, the booth is just here.